Okay, so transformation. So this is going to be our final little topic before the exams. And with regards to exams, you should start to be looking back at the stuff that we did at the beginning of the year. And we'll have another one of those little pop quizzes. Remember we had one the other week? So we'll have another one of those soon. So remember, those are supposed to be guiding you to the things that you remember and the things you don't. So you need to start looking at those before the end of your exam. Don't just leave it just before the exam start to look back, because things like percentages and things we did a long time ago. And you've learned a lot of stuff, not just in maths and obviously in your other subjects too. So you need to get reviewing sooner rather than later. Alright, so transformations. So these are operations that move figures, and when I say figures I mean shapes or diagrams, from one position to another without changing its size. Okay? So the three transformations that do not change the size of the object are known as translations, reflections, and rotations. Now some of these words might be familiar to you, others not so much. So remember, transformation is the overall umbrella topic. Okay? Translation is a special type of transformation. The reason I'm saying those over and again is because lots of people get it confused. So transformation is a general name, translation is a specific type. And that's the one we're going to start off with. So translation. Okay? So translation is where a figure is picked up and moved to another position. Okay? So you imagine it on a grid, it's just literally shifted to a different position on that grid. The movement that it is, how it's moved is described using what we call a translation vector. Okay, so it's a vector, again, fancy words here. So this describes the horizontal movements and the vertical movements. So the top number, so see it's in a bracket, and there's no divide line, so lots of people think it's a fraction. There's no line between them. So the top number tells you the horizontal movement. Okay, so that means left or right. If the number's positive, it's moving to the right, and if it's negative, it's going to move to the left. The bottom number is the vertical shift, so that means up and down. And again, if it's positive, it's going to be moving up. If it's negative, it's going down. Okay? So each point on the figure is moved by the same vector. Okay, you can either move each of them separately, or you can just use one point and then redraw your shape from that. Okay? So it's up to you how you decide to translate things. So here's some examples. So our original figure is that triangle just there. Alright, now I haven't labelled my axes, which is a bit naughty, but we're assuming each of these squares is worth 1. Okay? So we'll do two different types. We'll do both different ways of doing it. So our first translation vector we're looking at is this green one. Okay? So the green tells me 3 and 2. What did the top number tell me? Which movements did the top number tell me? Georgie? Right or left? Now which way will we go? Right, okay, so this tells me I'm going 3 units to the right. So let's do the move each separately. So we're going 3 units to the right. So if I'm focusing on this point to start with, I'm moving 3 units. So from here I'm counting 1, 2, 3. And then what was the other number? 2. And what does that tell us? We're going 2 units up. So we're going 1, 2. So we're moving to this position here. Okay, so I moved 3 units across and 2 units up. I'm now going to look at this point, and I'm going to move that point 3 units across, 1, 2, 3, and 2 units up. So that's going to be here. And then this point, 1, 2, 3, 1, 2 is going to be this. And then you redraw your shape. So you should see that your triangle has not changed size, it has not changed shape, it's just changed position.
Do you start counting from the triangle or do you count by the next?
So I had my point on here, and then you count 1, 2, 3. Okay, so however. All right, so that method there, I chose 3 of the points on my triangle, and I moved each of them by the same vector. Okay. This next example, I'm going to choose 1 point and then just redraw my shape. So the next one is -5, 4. So Madison, how am I going to move my shape this time?
You're going to move to the left.
To the left, how many units?
5.
Good, and okay. So I'm going to have this bottom right-hand corner as my focus point, and I'm going to move that point 5 units left and 4 units up. So I'm counting 1, 2, 3, 4, 5. 1, 2, 3. Oh. 4. So I moved 5 units left, 1, 2, 3, 4, 5, and 4 units up. 1, 2, 3, 4. That's where my point has gone to. Okay, so I moved 5 units left and 4 units up. Now, rather than to keep moving everything, what I'm going to do is just redraw my shape. Well, I can see that the point I moved was the bottom right-hand corner. So from there, I need to go up 2, and then I need to go left 1, and then join those up. So my point that I moved was this bottom corner. So that from there, my shape goes up 2, and then it goes left 1 to form my triangle. Do you see what I mean? So I just moved 1 point, and then I redrew it. Now, if that is like, whoa, what's she doing? Just go back to the other method. Okay, you get to choose which one you prefer. Does everyone understand? No, so remember, you're resting your pencil on a point and then start counting. Okay? Because you actually have to move it, that number. Because if you counted that as a point, you'll be going 1 less than you should be.
Does it always have to be that point? Or is there like...
No. I just chose that one because...
Should it be any point in the triangle?
Yes. Okay, and the last one is a -7, -8. So we're going which direction, Abby? Left, how many?
7.
And
Down 8.
down 8. Good. You're going to do that one, and then we're going to check that it's right.
Does it have to be these and this?
Pardon?
Or these and this?
What down where? Well, you're going to move this left 7 down 8.
Does it matter which point we move?
No. Now I just did the other one in red, and that one should have been orange. Sorry. Because this last one is blue. So mine is...
Oh, that was orange? I took these out.
So I'm going to do -8 in blue.
It looks red, it's okay.
Okay? So this time, I'm going to focus on this point. So I'm going to move it left 7, 1, 2, 3, 4, 5, 6, 7, and down 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so here's my new point. But this time, that means I'm going to have to go across 1, up 2, and then down. Okay? Now, obviously, you've got now the black original triangle and 3 pencil triangles on yours. Can you please make sure you label them somehow so you know which one was which?
Color coding.
When you come back and look at this later, you're not necessarily going to remember how we did that. You're just going to have a picture with different, bless you, 3 different triangles on there. So can you make sure you're labeling either color coded or label the vectors A, B, and C, and then you can label your triangles A, B, and C. I don't mind how you label them, Just make sure it's clear that when you come back to look at it another time, that you know what's going on. Yes, like ignore the axes as though they weren't there. Now, the reason that we do it on a set of axes is that it might be that my original shape could have been labelled A, B, C. Okay, so they could have labelled that triangle A, B, C. And they may say, having translated by the vector -7, -8, where does point A end up? And so what you would have to be able to do is to look at your original point A and see what coordinates that has. Now, what coordinates does my original point A have? Let's have a refresher on coordinates. Mylene, what's the coordinates of point A?
Well, it's hard because we haven't labeled the axes.
I said they're all worth 1.
Oh. What's that one?
Pardon? 2, 1. Good girl. So point A has the original coordinates 2, 1. You said
Okay. I don't get that.
Coordinates? You don't remember coordinates?
Oh, yeah, I do. But how do you get that?
What do you mean, how do you get that?
You label.
But if you remember coordinates, you should remember how to get that.
No, but why? Okay, that's what.
I'm talking about point A. I've labelled this as point A. And that point A would have the coordinates 2, 1. What do you know? What do you remember about coordinates?
Well, I remember that they do like one, do it go across the.
Okay, so how have I got to point A? That's why it's got the coordinates 2, 1. Yes? Yeah, sure. Okay, so this has the coordinates 2, 1. They may say, what's the new coordinate for that point? So we have to look down at our new, mine's blue. Okay, so I look down at my blue shape. The coordinate that corresponds to that would be this one here, yes? Now, often when we have images, so this would be known as an image, we would label it A dash, B dash, C dash. Okay, so they'd have a little apostrophe to show that it's not the original, it's having had a transformation done to it. So, A dash. So we now have to establish what the coordinates for A dash would be. So we now have to have a look. So have a look on your diagram. As I said, I didn't label all the axes. Picture we're counting. Count is what the coordinates A dash has. What's the coordinates of A dash?
I don't know how to do that either.
You don't know how to do the -1. So remember, we label our negatives, -1, -2, always label from the center.
Maybe -1 on
Okay, so you're just looking at it where those points meet. So we're looking at A dash. What did you say, N-squared?
-5, -7.
-5, -7.
How do you know which one to go first?
Okay, the x-axis always comes first. X comes before y in the alphabet. So your movement across comes first. So this point here is in line with the -5, and then the -7 comes second. Does everyone have the same coordinate?
Yeah.
Sarah, do you understand that?
Okay, so time is not with it. Done.
Each time you start with 1. Yeah, so I said that each of my squares representing 1. Now, on a different scale, different axes, you could have a different scale. So you just have to read your scale. It should be if they're asking you to do this. Now, let me just make it clear, they don't always ask you this information. But I'm just explaining that that's why we normally put it on a set of axes, because they might do. Okay, is everyone clear on that?
On the bottom, I think this might have to be for this separate one.
For my axis, oh, I just got to negative 7 because that's what I needed. Okay? Now, the important thing from this, though, is can you translate a shape? You understand how to translate something. Okay? So the top number in your vector tells you your horizontal movement, and the bottom number tells you your vertical movement. Okay? See the other question? No? Okay. Right, so that's actually doing the translation. Now, the second page shows, well, we have our original one, so it's the black L shape, and then we've got several different coloured L shapes after it, yes? So sometimes we're asked to describe those translations, okay? So we have to say, right, how has one shape moved? So your black one is your starting position for all of these. Let's do the first one together. So let's do A together. So can you all find shape A? It's that purple one. Yes? Now, in a similar way to the way that we translate the shape, you can select any of those points on the original and see what movement it makes, or what movement you have, or how do you have to move that to get to its corresponding point. Now, what I mean by that is we're not going to choose this point here and then say how does it end up to be this point here, because that's the closest one. Okay? Now you chuckle, but I've seen it happen. Right? Do you all understand what I mean by its corresponding point? So if I've selected this one as my point that I'm looking at, you're going to say how does that move to end up at this point down here?
And can we write it in words?
Okay? No, you're going to write it as a vector. So we just talked about vectors, yes? So how they describe it to you, you're going to describe it to them. So down here at the bottom, you've got A, B, C, D, E. You're going to do a tall bracket, and then the number that at the top tells you which movement, left or right or up or down. Left or right, and then the bottom number tells us up or down. Right, so let's have a look. So, which point shall we choose?
The bottom right one.
The bottom right.
No.
Okay, so M squared wants to move this point here. Okay, so we're going to say, how does that point end up down here? So your starting, your finishing point is important. So you've got to know which one you started at. So in our case, it's the black one. So we've gone from here, we've had to go how many left or right? M squared?
2.
2 what?
2 on left.
2 left. So that means it's going to be which value?
-2.
-2. Perfect. And then have we gone up or down?
Down.
Down. So we know our number's going to be negative. So we moved across 2 and we've gone down 1, 2, 3, 4, 5, 6. Perfect. So we've gone down negative, or we've gone to -6. So we've got -2, -6. Yes?
Yeah.
I'm going to pause this and you're going to have a go at some of the others. Pardon? Yes, that's perfect.
Because they're a bit close.
And have some answers. So, what did we have for B? Sarah?
I had -0.
Did everyone have that?
Yes.
Perfect. So yes, a few people asked me questions about the 0. You do have to have 2 numbers there. So if it hasn't moved in one direction, so if it hasn't moved left or right, you have 0 on the top. And if it hasn't moved up or down, you have 0 on the bottom, like that one. Okay, so C. Abby?
-7, 2.
Everyone agree with that?
Yes.
Perfect. D. J?
4, 4.
4, 4. Everyone agree with that?
Yeah.
And E. M squared?
3, -3.
3, -3. We all agree with that?
Yeah.
Perfect. We are now queens of translation.